Hi students, today we will go through the first unit of engineering geology. So we will discuss about introduction, relevance to civil engineering, branches of geology, scope of engineering geology, terminology, types of weathering, geological work of natural agencies, geological timescale, and then minerals and physical properties of minerals. So, the science of geology is all about the earth and the rocks of which it is composed, is about the processes by which they were formed during geological time and the modeling of the earth's surface in the past and at the present day. According to the directory of the Association of Engineering Geologists, engineering geology is defined as the discipline of applying geologic data, techniques, and principles to the study of naturally occurring rock and soil materials and surface and subsurface fluids. Interaction of introduced materials and processes with the geologic environment so that geologic factors affecting the planning, design, construction, operation, and maintenance of engineering structure, that is fixed works, and the development, protection, and remediation of groundwater resources are adequately recognized, interpreted, and presented for use in engineering and related practice. So, what is the relevance of engineering geology to civil engineers? So, most civil engineering projects involve some excavation of soils and rocks or involve loading the earth by building on it. In some cases, the excavated rocks may be used as constructional material, and in others, rocks may form a major part of the finished product, such as motorway cutting or the site for a reservoir. The feasibility, the planning and design, the construction and costing, and the safety of a project may depend critically on the geological conditions where the constructions will take place. Now comes the branches of geology. So here are a few important and well established branches of geology. First is physical geology. So, physical geology deals with the origin, development, and ultimate fate of various surface features of the Earth and also with its internal structure. The role played by internal agents, that is, volcanism and earthquakes, and external agents, wind, water, and ice, on the physical features of the Earth makes major areas of study in physical geology. Then comes geomorphology. This branch, although a part of physical geology, deals specifically with the study of surface features of the earth, primarily of the land surface. Detailed investigations regarding development and disposition of mountains, plains, plateaus, valleys and basins, and various other landforms associated with them fall in the domain of geomorphology. Then comes mineralogy. Minerals are the basic building units of which the solid crust of the earth is made up. This branch deals with the formation, occurrence, aggregation, properties, and uses of minerals. Petrology. Formation of various types of rocks, their mode of occurrence, composition, textures, and structures, geological and geographical distribution on the earth are all studied under petrology. Historical geology. It deals with the past history of the Earth as deciphered from the study of rocks and features associated with them, rocks may be treated as pages of the Earth's history. They contain within them enough evidence indicative of nature and time of their formation, composition, constitution, magnetism, structural disposition, and in many cases fossils, that is, remains of ancient life, all of which, when interpreted scientifically, reveal a lot about the events that have passed since their formation. Thus, fairly accurate estimates can be made from the above evidence about the climate, biological, and environmental conditions prevailing just before, during, and after the formation of these rocks in and around the areas of their occurrence. Then comes economic geology. This branch deals with the study of those minerals and rocks and other minerals, fuels, etc., occurring on and in the earth that can be exploited for the benefit of mankind. And now comes scope of engineering geology. So the basic object of a course in engineering geology are twofold. First one, it enables a civil engineer to understand engineering implications of certain conditions related to the area of construction which are essentially geological in nature. Second, it enables to understand the nature of geological information that is absolutely essential for a safe design and construction of a civil engineering project. Let's go through some terminologies used in engineering geology. So, weathering. So, what is weathering? Weathering is defined as the process of decay and disintegration of rocks under the influence of certain physical and chemical agencies of the atmosphere. The decayed and disintegrated product remains generally at or near the parent rock body because the weathering agencies do not involve themselves in the removal of the end products to any significant distances. Erosion. It is rather a broader term signifying the breakdown of rocks of the crust by such natural agencies that are characterized with some motion as wind, flowing water, and moving ice. By virtue of their velocity, these agents do not only gradually disintegrate the rocks but also remove the broken particles and fragments to far off distances ranging from few meters to hundreds and thousands of kilometers. Then comes denudation. In Latin, denudare means to uncover. It is a general term expressing the sum total of the processes of weathering and erosion operating for a geological, that is, long time in a certain region. A denuded landscape is one that has been produced and is presently exposed as a proof of the collective work of the agencies operating in that area. Then comes types of weathering. So here, first let us discuss mechanical or physical weathering. So it is a natural process of in situ disintegration of rocks into smaller fragments and particles through essentially physical processes without a change in their composition. A single rock block on a hill slope or a plain, for instance, may be disintegrated gradually into numerous smaller irregular fragments through frost action that in turn may break up naturally into fragments and particles of still smaller dimensions. Mechanical weathering is one of the very common geological processes of slow natural rock disintegration in all parts of the world. Temperature variations and organic activity are two important factors that bring about this change under specific conditions. Temperature variations are held responsible for extensive mechanical weathering of rocks exposed on the surface. These manifest in two different ways: frost action in cold, humid regions, and thermal, that is, insolation in hot regions. Then comes chemical weathering. It is a process of alteration of rocks of the crust or of the earth's crust by chemical decomposition brought about by atmospheric gases and moisture. The chemical change in the nature of the rock takes place in the presence of moisture containing many active gases from the atmosphere, such as CO2, nitrogen, hydrogen, and oxygen. As we know, rocks are made up of minerals, all of which are not in chemical equilibrium with the atmosphere and around them. Essentially, it is a process of chemical reactions between the surfaces of rocks and the atmospheric gases in the direction of establishing a chemical equilibrium. The end product of chemical weathering has a different chemical composition and poorer physical constitution as compared to the parent rock. Some of the main processes of chemical weathering are solution, hydration and hydrolysis, oxidation and reduction, carbonation, base exchange, and formation of colloids. Then, role of plants and organisms in weathering. It is a well-known fact that plants and organisms also contribute towards mechanical disintegration and chemical decomposition of rocks of the earth crust. Plants. So, how plants play an important role? So, in plants, hydrogen ions are known to be released at the roots of the plant during their growth and metabolism. These ions are capable of replacing many different ions, that is, potassium, calcium, magnesium ions from the minerals and rocks surrounding the root system and make them available for use in plant growth. But in this process, the original minerals and rocks around the root system start undergoing decomposition and disintegration. Man himself is known to be the greatest destroyer of rocks. He has been breaking them since the very beginning for one purpose or other and making their use in a variety of ways. Now, geological work of natural agencies such as wind and river. So, wind is one of the three major agents of change on the surface of the earth, other two being rivers and glaciers. Wind performs work of erosion by at least three different methods. First one, deflation; second, abrasion; and attrition. So deflation, what is deflation? When moving with sufficient velocity over dry and loose sands or bare ground covered with dust, it can remove or sweep away huge quantity of the loose material from the surface. This process of removal of particles of dust and sand by strong winds is called deflation. Then comes abrasion. A wind becomes a powerful agent for rubbing and abrading the rock surfaces when naturally loaded with sand and dust particles. This type of erosion, involving rubbing, grinding, abrading, and polishing the rock surfaces by any natural agent with the help of its load, while passing over the rocks is termed as abrasion. Attrition. The sand grains and other particles lifted by the winds from different places are carried away to considerable distances. During this journey, the particles are not moved in straight lines for the simple reason that all the particles are not of the same weight, and the wind velocity also varies from base to the top of the current. The grains are, therefore, moved in a zigzag fashion, colliding with one another again and again. These repeated collisions cause lot of mutual rubbing due to impacts. The wear and tear of large sediments suffered by them due to mutual impacts during the transport process is observed in wind as well as rivers. It is termed as attrition and is primarily responsible for reduction in size of the load particles during their transport. Rivers. Geological work of rivers. So rivers are capable of exerting greatly modifying influence over the topography of the region through which they flow. This modifying influence on the topography of a region by any natural agent is called its geological work. The running water performs its erosive work in five ways, that is, hydraulic action, cavitation, abrasion, attrition, and corrosion. So hydraulic action. So it is the mechanical loosening and removal of the material from the rocks due to pressure exerted by the running water. Cavitation is a distinct and rare type of hydraulic action performed by running water. It is particularly observed where river water suddenly acquires exceptionally high velocity, such as the location of a waterfall. Corrosion. The slow but steady chemical, especially solvent, action of the stream water on the rocks is expressed by the term. Now, geological time scale. So, what is geological time scale and what's its significance? So, as everybody know, radioactive dating, and everybody had heard about radioactive dating. So, radioactive dating has allowed the determination of fossils found in different sedimentary rock samples. It has allowed to calculate the presence of different organisms preserved in the rock samples in the form of fossils. In addition, it helped in predicting that Earth is nearly 4.5 billion years old and life appeared on Earth almost 4,000 million years ago. Since then, the Earth's history has been divided into five different time frames called as eras. Some of these eras are divided into the periods and which in turn split up into the epochs. So the various eras are as follows. First era, Archaeozoic era, that is 4600 to 3500 million years. So it is the first era which begins with the formation of Earth and presence of our solar system. There are no fossil forms available from this era. Then came Proterozoic era. It is the second era, or you can say it was the second era, which begins with the origin of prokaryotes, primitive metazoans, and eukaryotes. Reports are available about a very few fossils in this era. Then came Paleozoic era. that is from 570 to 280 million years. It was the third era, which is also known as an era of ancient life. Invertebrates, fishes, amphibian, etc. appeared in this era. It has been reported that spore-bearing plants, tree ferns, and origin of conifers emerged in this era. Reporting of a very few fossils is also available about this era. Then came Mesozoic era, that is from 225 to 135 million years. So toothed birds, mammals, reptilians, and dominantly dinosaurs were appeared. Additionally, placental mammals were also found. Cycads and flowering plants were also available. And Cenozoic, the last in this is Cenozoic, that is modern era. So this is the modern era and it witnessed the dominance of present age man, modern mammals, birds, fishes and insects. Minerals. A mineral is a naturally occurring inorganic solid substance that is characterized with a definite chemical composition and very often with a definite atomic structure. Mineralogy is that branch of geology which deals with various aspects related to minerals, such as their individual properties, their mode of formation, and mode of occurrence. So, here are some physical properties of minerals. First one is color. So, the color of any object is a light dependent property. A mineral shows color of that wavelength of the white light which is not absorbed by it by virtue of its composition and atomic structure. In nature, minerals of all perceivable colors are known to occur. On the basis of color, a mineral may belong to any one of three types. That is, idiochromatic means fairly constant color. Allochromatic having variable color and pseudochromatic that is having false colors. Then comes luster. Simply defined, it is the shine of a mineral. Technically speaking, it is intensity of reflection of light from the mineral surface and depends at least on three factors: the refractive index of the mineral, the absorption of what? Of light, capacity of the mineral, the nature of reflecting surface. Then comes hardness. It is a fairly constant and diagnostic property of minerals. Hardness may be defined as the resistance which a mineral offers to an external deformation action such as scratching, abrasion, rubbing, or indentation. Hardness of minerals depend upon its chemical composition and atomic constitution. Then cleavage. It is defined as the tendency of a crystallized mineral to break along certain definite directions, yielding more or less smooth plane surfaces. In other words, cleavage planes are the planes of easiest fractures in are essentially indicative of directions of least cohesion in the atomic constitution of a mineral. Tenacity. The behavior of a mineral towards the forces that tend to break, bend, cut, or crush is described by the term tenacity. Specific gravity. The density of a substance is a fundamental property of great importance and is defined as the mass per unit volume. of the substance. In mineralogy, the term specific gravity is used more frequently than density and signifies the ratio between the density of a mineral and that of water at 4 degrees Celsius. It is a misprint here, that is 40, but it is 4 degrees Celsius. So read it as 4 degrees Celsius. Since it is a ratio, it has no units. So in today's lecture, we learned, we gone through the introduction of the subject, then how geology is relevant to civil engineering, then we discussed branches of geology, then we talked about scope of engineering geology, various terminologies used in engineering geology, then went through types of weathering, we discussed geological work of natural agencies, geological time scale, minerals and their physical properties. So kindly refer the following library for available textbooks on various subjects and your own syllabus and courses, and it is an initiative by National Digital Library of India, and it's an initiative by MHRD and Indian Institute of Technology Kharagpur. So you can simply log in here, you register yourself, and you can explore many books regarding your subject and your syllabus. So hope you will enjoy this link. So thanks. Stay home, stay safe, maintain social distancing. Let us fight against COVID-19 together. Good luck.